signal will travel, okay? Let's just backtrack a little bit now and look at the difference between tracing a pipe and tracing a cable. You might be able to relate to this in the real world, guys. When you put signal onto that cable, it is an insulated cable. So effectively what that signal is trying to do, remember this, guys, that signal is trying to get from A to B. That's the best way to understand it, all right? So that signal is coming down this insulated cable. The cable's insulated, remember. So it needs to get off the cable. It needs a contact with ground to get off. So what it's actually looking for is an earth. Yeah, exact, spot on, yeah. So just imagine this. It's going to come down here, up into there. That electric cable is bonded to the metal pipes underneath and comes down and it comes back. Does that make sense, guys, again? All right, so it's kind of got to run down it, you know, to the next lamp column or a point in the ground. Now, consider this. What if that was a metal pipe? What is the difference? Well, a metal pipe, most metal pipes anyway, not all, are in contact with ground, aren't they? There's no insulation on them. So if that was a metal pipe, that signal is going to travel along it, but all the time it can leak off and come back. So to translate that to real world tracing, what you tend to find is that when you're tracing a pipe, as you walk along the pipe, the signal's dying off very rapidly. You've got to keep compensating for that by turning your sensitivity control up. When you're tracing a cable, you tend to find it's much more constant. One of the things that come up as well was from Joe, the condition of the LV main. Absolutely. Yeah, you sometimes find with these old mains where the insulation's a bit corroded and stuff, it leaks off much quicker. Yeah, it's a bit more like a pipe. Does that make sense, Joe? I think that's what you're referring to on that. Okay. Yeah, and sometimes it's not just a case of jumping, Zach. It's just coming back down something else. So think about return paths. Yeah, that signal's getting back to here. If there's something else going this way that's a conductor, it will travel down that as a path of least resistance. Yeah, so that's why we can get signals kind of jumping, if you like, you know. And also, don't forget, guys, what it can also do here. Let me show you this. Yeah, think about this one. So that signal is going to come down here, up here, into that house, down on the metal pipe, back out on the metal pipe, and down the metal pipe. Yeah, that can happen. Does happen. Generally it's much weaker though. Yeah, and especially because the pipe's deeper as well, typically. Okay. All right. Also, back to what I said about pipes, guys. Bigger pipe, the harder it is to get distance down it. Can you see that? Because you've got more surface area in contact with ground, so it leaks off quicker. So have you experienced that before, guys? Have you ever noticed the difference between tracing a pipe, tracing a cable, and it's down to the insulation? And if anybody's ever traced a high pressure gas pipe, trace it for a considerable distance. So that kind of is contradicts my argument, yeah. But there's a difference because a high pressure gas pipe is insulated. It's coated, you see. So we go further on. Okay. Is everyone with me so far, guys? Yeah. Let me know I'm making sense and I'll move on. So we've talked about pipes and cables, yeah? Now let's go back to our signal splitting now.